Let's discuss another example and understand how balancing of redox reaction occurs through oxidation number method. So we will take example where we will take phosphorus that reacts with HNO₃ to give us HPO₃ and NO along with water. So what was the first step? First step, if you remember, was that write the oxidation state of each atom that is going to change their oxidation number. Usually oxygen doesn't change their oxidation number during a reaction. It is not that it can't change, but mostly we observe that oxygen is not changing its oxidation state. Usually atoms other than oxygen and hydrogen are changing their oxidation state. So for example, in this reaction you will have oxidation number of phosphorus at 0 and nitrogen in nitric acid has oxidation number 5. Here phosphorus is in oxidation state of there is -6 plus 1, so this will be in let's calculate. Phosphorus has X plus 1 of hydrogen and 3 plus 2 into 3 into -2 for equals to 0. So what is the oxidation number coming out? Plus 1 minus X equals to 0. So X is coming out to be plus 5. So I was right. Oxidation state of phosphorus is 5 and in this oxidation state of nitrogen is plus 2 and water we are not considering out here because hydrogen and oxygen are not changing their oxidation state. Now what you have to do is check that phosphorus is going from 0 to plus 5 oxidation state. Phosphorus is going from 0 to plus 5 oxidation state. So increase in oxidation number is happening. So increase in oxidation number means that oxidation is happening. Phosphorus is undergoing oxidation and in from nitric acid to NO formation involves from plus 5 to plus 2. The decrease in oxidation number is happening. So the decrease in oxidation number is happening when we are going from nitric acid to NO. So this is basically reduction. This is reduction. Alright. Now you can see we have one phosphorus atom, one phosphorus, nitrogen, same, and we have to see what is happening. Hydrogen atoms, we have one, over here we have 2 plus 1, 3 hydrogen atoms this side. Now let's see, we have to make increase in oxidation number equals to decrease. So first of all, let's see what is the increase in oxidation number. Total increase in oxidation number, total increase in oxidation number equals to 5 and decrease in total decrease in oxidation number, total decrease in oxidation number is from plus 5 to plus 2, that is 3 units. So decrease is 3 units and increase in 5 units. We have to make increase and decrease equal. So what we will do, we will multiply phosphorus and HPO₃ by 3 and we will multiply that this and NO by 2. By 5. So 3 into 5 will be 15 and 5 into 3 will be 15. We will make increase and decrease equal. So we will multiply this 5 into 3, that is 15. So we will multiply this by 3 and this by 3. Similarly, what we will do is we want to make increase equals to decrease. So increase is 15, so decrease should be 15. So we will multiply this by 5. So we will multiply this nitric acid as well as nitric oxide by 5. Now you have total decrease equals to 15 and total increase equals to 15. So we have balanced decrease with increase. Now let's see. We have 3 phosphorus, we have 5 nitrogen, we have 5 nitrogen, we have hydrogen 5, and how much hydrogen you have out here? 3 hydrogen here and 2 hydrogen here. So you have 5 hydrogen. Oxygen, 3 5s are 15 oxygen, 3 3s are 9, 9 plus 5 you have 14 and in water 1. So you have 15 oxygen, and we have in balance increase equals to decrease. So you have already got a balanced redox reaction which we have balanced through oxidation number method. So this is the balanced redox reaction through oxidation number method. So that is how you can do more practice, and for that we have given few examples out here which you can practice and get confident on this topic. Thank you.